and within the Brazilian biodiversity sphere. And we can also thank them for their work and dedication, and mainly I'd like to thank everyone for their presence, especially the speakers who have dedicated time to show their knowledge, to share their knowledge with us, and the supporters of the event, USAID and US Forest Service. Also, I'd like to congratulate all organizers led by the UNB and CENAP and ICMBio. I'd like to thank them for all the efforts made to carry out the workshop. This has to do with the national plans of conservation for Brazilian ungulates. And it will approach a very important issue, which is the translocation of Brazilian ungulate species, which is a very necessary measure to conserve our tapirs, deers, and peccaries. I wish we had better circumstances for the event, but it is a sad day, and we send our condolences to Bruno Pereira's and Dom Phillips's families. Now I will hand the floor to the coordinator of the University of Brasília's lab, André Cunha. Thank you, Ronaldo. Hello, everyone. Good afternoon. I would also like to extend my condolences. As Ronaldo mentioned, this is a very hard situation for us in Brazil, as you all are aware. But we must continue and keep working. I'd like to thank everyone here in the room, a room full of experts and professors from whom I've learned quite a bit, and I continue to learn. Congratulate Professor José Ronaldo Fragoso and everyone at ICMBio and Gonzalo at TSE for organizing the event, TSI actually. This is a very important event. When I first started studying ecology a few decades ago, we had to understand ecological interactions and the determinant drivers of species to understand species in those environments which we thought of as primitive, where they had evolved. But we know this has changed a lot, and now we have to look at the changes in these environments. I'm very happy to be here looking at biodiversity conservation, not only in terms of preserving what exists in the environment, but also to restore biodiversity as it was a few decades ago. So we know that this is the reality of conservation of biodiversity around the world, in Europe, in the United States, and also in Brazil and Latin America. And to me, it's an honor to learn from you. I'm very happy to be here in this workshop to understand these new aspects of ecology and conservation, which is something that we need to pay attention to. And there is a lot to be developed in Brazil. Today, we have more than 2,000 individual types of monkey lions, and many other species of monkeys in the Tijuca forest. Maybe the muriqui species will be seen there soon. And this is very motivating to be here in such meeting. The University of Brasília has been supporting us here in Brazil so that we can better understand these realities in different parts of the country. We are a continent-sized country, so when we talk about species here in the Cerrado region, we have species that are extinct in the Atlantic rainforest, but that are quite numerous in the Amazon and in the Pantanal region. So we must understand how to manage these populations and the impacts on biodiversity. This is one of the goals of this workshop. So welcome everyone again, and I am at your service for anything that you might need. Thank you. Thank you, Andrea. Let's go to our first speakers, Mr. Rodolfo Dirzo, professor at the University of Stanford, who will be talking about the first item of the day. Thank you, everyone, for your presence. And please, Rodolfo, go ahead. You're on mute.
Okay.
What about now?
Thank you so much, Mariela, and thank you so much, everybody. I cannot start without joining and expressing my sadness because of the sad situation we have experienced and learned in these last few days and weeks of the suffering with the loss of those two dedicated persons to the conservation and well-being of humanity by doing the conservation and protection of the Amazon. I'm so sorry to learn about the loss of Bruno and Don Phillips. I wanted to check, Mariela, if I can use my presentation. I have an updated presentation, which is much more complete. Could I possibly share my screen?
Okay, that's no problem.
Thank you so much. I hope you can see what I'm showing now. Is that the case? Can you see?
Yes.
You can make it full screen, Rodolfo.
Rodolfo, you must microphone.
Is it working now?
Yes, perfectly.
Fantastic. Thank you so very much, and my apologies for
No
these limitations on my part. I want to share with you some reflections on the two processes that are at the heart of our discussion in this workshop these 2 days, which have to do on the two phases of the same situation that we want to look at today. One is the loss of wildlife, what I am being calling defaunation, and then the opposite of that, the process of bringing that loss, fixing that loss in terms of the refaunation. And of course, I want to look at this in terms of what is happening today in what is called the Anthropocene. I want to think that what Joe suggested to me, Professor Fragoso suggested to me, is that I provide an overview of these two phenomena as a preamble to our discussions in the last presentations and today and tomorrow. Let me start really from a very macroscopic point of view. We are blessed as a species that we have evolved at a time in which the diversity of the planet is at its maximum expression. As you all know, the long process of evolutionary diversification of the planet has taken about 4,000 million years, what in the US is called the 4 billion years of evolution. But what we have today is an incredibly beautiful and hyper-diverse planet, perhaps like never ever in the history of life on the planet we have had before. Although our friends...
Sorry, Rodolfo, I'm sorry for interrupting you. Are you sharing your screen? Because for us, we doesn't see.
Wow.
Yeah, so
Okay.
initially, Rodolfo, we could see your screen and we couldn't see you, and now we can see you and you look great, but we can't see your screen.
Okay, let me try again. Is it working now?
Now we have both, yes.
Yes.
Okay. Again, my sincere apologies, friends. I'm so sorry. I want to talk about this connection between defaunation and refaunation. My first argument was that we are blessed in having such a beautiful planet after a long process of evolutionary development, in which we have an incredibly beautiful and hyper-diverse planet, including animals that we see in this slide. Although our friends in the world of marine sciences tend to think that we live in a blue planet, which is correct because of the coverage of the planet with the oceans. But I think we have to recognize that we have a planet which is also green in terms of vegetation and the terrestrial wildlife that lives on this beautiful green planet. This wonderful legacy that we have of animals on the planet today is perhaps expressed in our current times in the diversity of wildlife that we have in the African continent that maintains the wildlife that includes the megafauna, as you can see in this slide. Beautiful decoration that we still feel so proud and so careful about hoping to maintain on the planet. If we move on to our area of the planet in Latin America, although we don't have such an equivalent megafauna as diversified as in the African continent, we do have our megafauna as well. After the extinctions of the Pleistocene, what we have been left with is this amazing megafauna, some examples of which you see here, including some that are very representative of the wildlife in Brazil, in the Amazon in general. Going from medium-sized animals such as the kinkajous, Potos flavus, to the spectacular tapirs and giant anteater and the spectacle bear, and of course the carnivores such as the jaguar. We are blessed in a region of the planet in the sense that of the incredible mammalian diversity that now accumulates getting close to 6,000 different species. We have a very high density of those animals in the Brazilian, in the Amazon, in the Brazilian region in particular. As you can see here, the intensity of the red colors, of the red pixels in this image, shows that although we do not have the spectacular megafauna that is present in, say, Central Africa or in the African continent in general, we do have a tremendous diversity of species. Really, this is a spectacular region in the sense that no other region of the planet accumulates such a legacy of diversity in the mammalian clade. As you, I'm sure, are aware, we keep on discovering new species, even in this group of animals, which are visible, large body sized, and so on. Here's a representation of a relatively recent paper by Paul Ehrlich and Gerardo Ceballos, showing species that represent the new discoveries that we keep on accumulating. On the bottom right, you see one of the most recent ones, the Olinguito from Ecuador, a medium-sized procyonid that has been discovered, amazingly enough, just very recently. Even more amazing, to me anyway, is the discovery of these new species of tapir, just published in 2013. I mean, coming to think about the discovery of these incredibly visible species is an astonishing fact that we can consider as a wonderful representation of what we have on the planet in terms of this legacy of biological diversity as represented by these animals, including ungulates. Unfortunately, this legacy, this decoration of the planet represented by the wildlife, particularly the mammals, is being heavily impacted by what has been called the Anthropocene. As most of you know, perhaps this is relevant for some students, Paul Crutzen, the Nobel Prize in Chemistry, in the year 2002, published this very short paper in Nature, addressing or actually complaining about the fact that we no longer should consider that we live in the Holocene, but rather we live in a new epoch or era of the Anthropocene. Given the tremendous footprint that we're imposing on the planet, this is the era of the anthropogenic global change. And as you all know, there is a number of manifestations as to what are the kinds of activities that we as society do that represent biological consequences in the Anthropocene. Here you see in this panel of graphs, you don't have to worry about the details of the slide, just you can see that for a number of variables, including population size, GDP, energy use, fertilizer consumption, water use, and so on and so forth, looking at the trajectory of those activities that we do as society, over the last 2 decades, there has been a tremendous acceleration, as you can see, essentially in all of these graphs, a tremendous acceleration of these activities that we as society do on the planet. And of course, needless to say, those activities have to be represented in terms of the consequences in what we could call the Earth systems that we have on the planet. On this section of the graph, or the slide, you can see that there's a number of manifestations represented in the Earth systems. Obviously, the most common ones, the most paid attention to, are things that have to do with climatic change or atmospheric phenomena, such as accumulation of carbon dioxide on the atmosphere, nitrous oxide, and so on and so forth, ocean acidification, surface temperature, and so on. Very few of these variables here represent what is happening to biological diversity. Although the three graphs at the bottom right, you can see the trajectory of tropical forest loss, or the conversion of land, a thing that is called in this paper domesticated land, and briefly just one graph addressing what is happening to animal and plant life in terms of the number of species that are being degraded, that are being included in the number of species threatened, as you can see in this graph here. But if we review the literature and we go a little bit deeper into what is happening to biodiversity in the Anthropocene, we have a number of metrics, a number of variables that represent this dramatic situation here. Please do not worry about checking all the details of this graph here, of this slide here, but I just wanted to show you that in a recent paper published just over a year ago, we analyzed a number of variables that represent the manifestations of the Anthropocene in terms of biological diversity on the planet. And I wanted to highlight particularly two of those, land surface at the top and the populations of vertebrates and wild animals towards the bottom. In this graph, what you can see in red color is the proportion of those variables that have been affected to some degree, and in the blue color, the proportion which has not been affected or not affected as significantly as has been happening recently. And as you can see, this line here of 50% shows that the vast majority of these drivers, of these indications, of these manifestations of activities on the planet in the Anthropocene actually are quite significant. And I want to emphasize particularly these two, land surface and terrestrial wild animals, because of the emphasis of our workshop today. Starting with land surface, I think that is an aspect that is relevant for our discussions today. We have what is a very well-known metric to illustrate, to document, to model, and even project what is happening with plant life, with the forested aspects of elements of the planet. And we use the metric of deforestation, a term that everybody in this workshop and everybody in the public also recognizes. We have this process of deforestation. And that represents very dramatically what is happening to plant life, to the ecosystems from the point of view of the plant life. Here's an amazing projection derived by the Global Forest Watch, indicating what must have been the intact forest 8,000 years ago. And 8,000 years ago is relevant because this is roughly the time when our species, the human population, began to massively expand and spread throughout the planet. The closed intact forests, those forests with a closed canopy 8,000 years ago, must have had this distribution at that time. Knowing the current rates of deforestation, this metric that I've been mentioning, we can project what would be the situation like if we continue with business as usual, with the deforestation rates that we have today going forward. We would end up with intact closed forests with a dramatic situation, as you can see in this slide. I wanted to use this couple of slides to illustrate my point that we can see by using satellite imagery and remote sensing technology the incredible impact that we can impose on our planet from the point of view of the ecosystems viewed with the lens of the vegetation. Unfortunately, these very vivid, dramatic, and really compelling images cannot tell us too much about what is happening with animal life. So as we have deforestation to illustrate this problem, we need to come up with a term that brings attention to the fact that we are dramatically also losing wildlife, we're losing fauna. And hence the term defaunation, a term that in our lab we have been using for some time now. And I think that we need to recognize that equivalent to deforestation, we have a problem of defaunation. Defaunation has been examined in very superficial ways many decades ago. Some of you might remember a classical paper by Oliver Phillips, published in the Annual Review of Ecology and Systematics some years ago, in which he looked at the situation of tropical ecosystems of the planet. And he mentions in that paper that the loss of animal is an invisible threat, because we did not have information as to what is happening to these components of biodiversity, the wildlife, the animals. And this set of, this collage of horrendous images that you see here do give you an idea that the situation with animal life is not a happy one. In fact, it's a very dramatic one. Of course, we had not accumulated quantitative information and detailed information about the trends and patterns and trajectories of the situation. But we're improving now, and we can have a very good picture to illustrate, to confirm that this is a very serious problem. By the way, at least these two photographs, these two photos in this collage are situations that I have taken photos of in the Amazon region. So let me very quickly try and describe for you what is the first element of our discussion in this workshop, which is the loss of animal life. Let me start with a macroscopic view and a very rough view by looking at animal biomass through the last 10,000 years. Here you see three bars in this graph. The one on the left indicates the biomass measured in terms of millions of tons 10,000 years ago. W here means wildlife. And red, this little section that you see here on top, probably see here on top, represents human biomass. 10,000 years ago, we had roughly 300 million tons of animal biomass. Most of it was wildlife biomass, the animals of the planet. Fast forward to year 1900, and you can see that we roughly have the same total biomass, but now the composition is very different. The red, which is humanity, Homo sapiens, increases quite significantly, but now a new element comes in, which is the domesticated animals of the planet. The consequence of that, given that we kept the same total biomass, is that W declined dramatically. The biomass of wildlife had declined dramatically by year 1900. If you move on to now, basically, on the right-hand side, the biomass of animals on the planet in year 2015, that is to say today, basically, two things become very apparent to you. The total biomass presents a dramatic increase now to 1850 million tons, but the composition is even more dramatic, a gigantic increase in the biomass of the human population, but even more dramatic increase in the biomass of the domesticated animals of the planet. All of that bringing about a tremendous reduction of the biomass of wildlife, of animals. So we live now in a planet in which we have transformed the organization in terms of this very crude measure, which is animal biomass, into a very dramatic situation where we have a tremendous dominance of domesticated biomass and human biomass. And of course, it is very easy for you in this call to imagine, in this workshop to imagine, what are the implications of this. For us to accommodate, for example, the domesticated biomass on the planet, we need to destroy the habitats to accommodate cattle ranching, grasslands for cattle grazing, those kinds of things. And of course, all of that is a phenomenon that contributes to the defaunation that we have today. A typical metric to examine, to pay attention to the fact that we're losing wildlife is the extinction, the global extinction metrics, or the global extinction estimates. And if you look at the IUCN red list of species, of endangered species, you can come up with a number of estimated species that have gone extinct, for example, since year 1500. Here you see a selection of some of my favorite, not favorites in the sense that they have gone extinct, but animals that I would have appreciated to have known, but we have lost, unfortunately, today. And you can choose the ones that you would prefer to see in this slide. The point that I want to make is that we tend to think of global species extinction as the metric to estimate this process of defaunation in the Anthropocene. Here I have a slide that shows some numbers published relatively recently by Professor Gerardo Ceballos and other zoologists. What you have here on the left-hand side is the number of species that have been recorded as extinct, unequivocally extinct. This is the case of vertebrates, 338. That number, however, is relatively low, as you can see. But the interesting thing is that if you look at the number of extinctions that have occurred more recently, exactly since year 1900, a great proportion of that is accounted for by the recent extinction. So almost 200 out of the 338 have taken place in the year 1900. If you look at the species 617, which includes a number which includes extinct in the wild, and in imminent risk of extinction, that number becomes 617. And of that number, almost 480 have become extinct since the year 1900. That is to say, even though these numbers can seem relatively low, we see a dramatic process of acceleration of the extinction, of the global extinction of the species. And of course, even though the numbers look relatively low compared to the background rates of extinction, in the case of mammals, the numbers that you see here, what we see today is that we have a trajectory which is 10 to 100 times faster than the background extinctions of vertebrates. So we tend to pay attention to the situation of extinction of global extinction of species as the metric to measure this problem of defaunation. A summary of what I was trying to say in the last slide is shown in this slide, in which you can see this phenomenon of acceleration. But again, the numbers are relatively small. So one has to ask the question, is it the fact that the low numbers of globally extinct species the correct way of assessing what is happening to wildlife on the planet? Is it a myopic view of the problem? I want to suggest that that is indeed the case, because there are a number of steps or a sequence of steps that are occurring that eventually lead to this number of global species extinction. But I think that these elements in the sequence are the critical aspects that we need to be paying attention to in our efforts of rewilding, reforesting, and restoring ecosystems. The processes are the local declines in abundance, which in the extreme condition brings about the contraction of the geographic range of the species. That contraction in the range of the distribution of the species has inevitably a consequence, which is the loss or the extinction of local populations, which eventually in the extreme situation leads to the global species extinction. So the numbers of species that are globally extinct can be a deceiving view of what is really happening and what is relevant, I think, in terms of the ecosystem processes, and also in terms of what is happening at the local level where humans in local communities live. So I want to elaborate a little bit on this sequence of steps for our discussions later on. Here you have a slide that shows the decline measured as using the Live Planet Index, an index that has become very common nowadays to estimate the annual rates of decline. Very simple. This live planet index is nothing but the ratio of the number of individuals of a given population at a given time compared to a previous time. The modeling is not too complicated, but essentially this is the numbers that you need to compile. When we did that in 2014, we estimated for the last 4 decades, from year 1970 to now, a decline of about 50% of the vertebrates over these last 4 decades. I'm sorry, of 25%. If you break down this global decline into regions, and one that we're interested particularly in this workshop is the situation in tropical vertebrates, we can see the actual decline we estimated to be dramatic, 50% in only 4 decades. The vertebrates of the planet had manifested a decline of 50%. I am amazed to see that the Live Planet Index report on its yearly assessment has come up with a more recent estimate, in this case for the year 2020, and they have come up with an even more dramatic situation. What they have estimated here is not the 50% for the tropics that we calculated in 2014. By 2020, this WWF, which is responsible for the estimations of the global living planet index, they have come up with a much more dramatic rate of decline of 65% in only just a few decades. So these numbers indicate that at a very rapid rate, we had estimated 50% and now 65%, we are declining the numbers of animals around the planet for those species that have been monitored using the metric that I told you. One consequence of that, as you can easily imagine, is that with those declines at a given location, when you look at them collectively, you begin to see the second element that I wanted to discuss with you, which is the contraction of the geographic range of distribution of the species. And here you have 3 dramatic, emblematic examples: the African elephant, the hippo, and the rhino. In the maps below, you can see in the bluish color what used to be the potential or the overall range distribution of the species, of these 3 species in the past. And now what you can see in these red polygons in the 3 maps, the areas in which these species are now restricted to. The implication of this, and of course this is my main point here, is that in those blue areas that do not coincide with the red polygons, we have experienced a dramatic loss of populations. Even though we do not have a good quantification of the number of populations that have gone extinct, these maps actually are clear indications that is happening at a very fast rate and is a dramatic loss. In a region, here I've chosen 2 examples to illustrate what could be essentially the same situation. On the left-hand side, you see the tapir in Mesoamerica. The light color area here in Mesoamerica represents the distribution of the animal, and the darker red polygons represent the areas where this animal is currently located only. On the right-hand side, you see a similar dramatic situation for the jaguar. You can see a distribution that went from the southern part of the US all the way down to South and South America is now restricted to what this is the current range. So these areas of the pale color here represent for these 2 species as in the same situation as I presented for the 3 herbivores of the African savannas, the dramatic loss of populations. My point can be illustrated in more detail, I hope, with this estimate presented for you in this graph. Here you have the sample of a number of mammals. For the period of 1990 to 2015, we have estimated the magnitude of the contraction of the range for this sample of mammalian species. And what you have in this graph is 5 categories of range contraction. The one on the left, the green one, is represents those species that have had a contraction of less than 20%. They have lost only 20% or less of the range. On the other extreme of this graph, you have in number 5, the category in which the species have contracted the range in at least 80%. And on the y-axis, you see the percentage of species that belong to each of these categories of range contraction. And most unfortunately, what you can see is that close to 50%, shy of 50% of the species in this sample have restricted, have reduced, have shrunk the range by at least 80%. Again, emphasizing that the real metric to examine what is happening to our wildlife today is this process of population extinction as represented by the range contraction, which is a result of the local decline of species. So although the numbers of globally extinct species are relatively low, there's the drama, really the real drama of biological extinction in terms of the wildlife, in terms particularly the mammals, is the loss of populations. That's where the problem lies. I think relevant for our discussion in the rest of the workshop today and tomorrow is to ask the question, what kinds of animals are critical for reformation programs? Given the fact that we have seen, as I have tried to illustrate in these previous slides, the drama of the loss of fauna, the defaunation, now we have to come up with a situation of what can we do about it? What can we do in terms of what would be called refaunation? First question about this is what animals are critical for reformation programs. Situation comes about that the animals present differentiated vulnerability. Not all animals are equal in terms of their vulnerability to being eliminated or to be made decline from the local habitats. Why? That is because there are two combined factors here. We humans have particular preferences for animals that we want to have an impact on in terms of, for example, food, amount of meat, or trade because of the species that have some animal characteristic that we find relevant for trading. The case of the ivory trade would be an example of that. The case of the pelts of jaguars would be another example of that. So we have clear preferences for animals. And we tend to use animals that have these characteristics in mass, in big numbers, or in big size. In addition to that, there's an intrinsic factor that has to do with the natural life history of the animals associated to the home range. And all of those things, the preferences that we have, we tend to prefer species which are diurnal, species which are large in size, species that represent some value for us in terms of food or trade and so on. And those species also have differential susceptibility. All of those characteristics are very conveniently for us